Hi, Mr. Wright here, and welcome to this video walkthrough of Summer 2023 Paper 2H. You can download the question paper by hitting the link in the description, and then you can attempt the paper before you watch the run-through, or you can work on the paper as you watch the run-through and work alongside me. Also in the description, you'll find links so that you can jump forward to the worked solution for a particular question if you want to save you watching the whole film through. If you find this film useful, please do tell me so in the comments. And if you have any questions, of course, leave these in the comments as well, and I will respond. Let's get on with the maths. Show that this is true. So I'm going to start with the division on the left. I'm going to work out its answer and show that its answer is 3 8/9. So I'm going to turn these mixed numbers into improper fractions. Now I'm going to keep, change, and flip. Now I'm looking for cancelling. 2 goes 3 times, 2 goes 7. Now I'm going to do top times top, 35. Bottom times bottom is 9. 35 over 9 is 3 8/9, which is what I was asked to show. So that is number 1. A bias spinner can land on green or on yellow or on brown or on pink. The table gives you the probabilities that when the spinner is spun, it will land on green, on yellow, or on brown. Okay. We spin the spinner 200 times, work out an estimate for the number of times the spinner lands on pink. Right, let's first of all work out this missing probability here. I know all those probabilities have to add up to 1, so I've got 0.32 plus 0.13 plus 0.28, which adds to 0.73. So pink, the probability of pink must be 1 minus 0.73, which is 0.27. So that missing probability there is pink. So it lands on pink. I would expect it to land on pink 0.27 of the time. So the number of times it will land on pink, if it's spun 200 times, I would expect to be 0.27 times 200, 54 times. That is question 2. Question 3. Right, so we've got a trapezium here, and the two parallel sides are BC and AD, and I've got to find the size of the largest angle inside the trapezium. Right, well, clearly I need to find x, and because it's a trapezium, I know that these two angles here add to 180. So I can write the equation 3x plus 46 plus 4x minus 27 equals 180. Right, tidy up that left-hand side. I've got 7x plus 19 equals 180, minus 19 from both sides, and 7x is 161, which tells me that x dividing by 7 is 23. Now, I'm asked to find the largest angle inside the trapezium. That's this one. So I need to find the value of 3x plus 46, and I know that x is 23, so it's going to be 3 times 23 plus 46. 3 23s is 69 plus 46, which gives me an angle of 115 degrees, and that is number 3 finished. Complete the table of values for y equals x squared minus x minus 4. So you could use your calculator for this one, of course. When x is 3, x squared is 9, take away an x. 9 take away 3 is 6, minus 4 gives me 2. When x is 2, x squared is 4, take away an x is 4, take away 2, which is 2, minus 4 gives you minus 2. X is 0, it's going to be x squared is 0, minus 4, minus 4. X squared is minus 1, so I'm going to have minus 1 squared, which is 1, minus minus 1, which gives me 2. Take away 4 gives me minus 2. X is minus 3 squared, minus 3 times minus 3 is 9, minus a minus 3 is 12, take away 4 is 8. Okay, now I've just got to plot these points without making a mistake. -3, 8. -3, 8. -2, 2. -1, -2. 0, -4. 1, -4. 2, -2. And 3, 2. There we are. Now I'm going to have to join these up. Nice smooth curve. So the minimum is going to be between these 2 points here. So it's going to look like this. Nice smooth curve going through the points. There we go. That is number 4 complete. Nancy has some coins with a total value of 85 pence. She has only 2 pence and 5 pence coins. The ratio of the number of 2 pence coins to the number of 5 pence coins is 1 to 3. Nancy has more 5 pence coins than 2 pence coins. Okay, how many more? Let's have a look. Well, the number of 2 pence to the number of 5 pence is 1 to 3. So if we have a think about the value of those coins, that's a 2 pence coin. One 2 pence coin is worth 2 pennies. And these ones here are 5 pence coins. So 3 5 pence coins worth 15 pence. Gives me a total of 17 pence. Now, she has a total value of 85 pence. So I'll write that down here. Now I wonder what that has been multiplied by. 85 divided by 17, that's been multiplied by 5. So of the 85p, 85 pence, 10 pence is made up of 2 pence coins, and 75 pence is made up of 15 pence coins, because 15 times 5 is 75. So that tells me that she must have how many 2 pence coins? Well, she's got 10 pence worth of 2 pence coins. She's got 5 2 penny coins. And she's got 75 pence of 5p coins, means that she has 15 5p coins. Nancy has more 5 pence than 2 pence. How many more? Well, she does have more 5 pence than 2 pence, because she has 15 5 pence and 5 2 pence. How many more? 10 more. That is question. Question 6. Write 76 million in standard form. Well, it's going to have to be 7.6 times 10 to the some power or other, and it's going to be times 10 to the 7. 6b, write 5.4 times 10 to the minus 4 as an ordinary number. Well, I'm going to start with 5.4, and I'm going to divide it by 10 4 times, or I'm going to move the decimal point 4 places. 1 place hops over the 5, so I'm going to move it 3 more places. So there'll be 3 zeros before the 5. So the answer is 0.00054. Question 7. A and C are points on a circle with the centre of O. DA is a tangent and DC is a tangent. ADC, this angle is 48. Work out the size of the reflex angle AOC. So it wants the size of this angle, but it's already marked there. I'll label it X. Right, looking at what circle theorems might apply, I've got a tangent and a radius, so I know that that's 90. And also at A here, I've got a tangent, AD, and a radius, so I know that that's 90. Now, have a look at this. This is a quadrilateral. And what do I know about the angles in a quadrilateral? I know they add up to 360. So I know that this angle here, which I'll call Y, must be 360 minus 90 minus 90 minus 48. 360 minus 90 minus 90 minus 48 means that Y is 132. So if this angle here is 132, I can work out X by doing 360 minus 132, which gives me 228. So the size of the reflex angle, AOC, is 228. 228. Question 7. A and C are points on a circle with a centre of O. DA is a tangent and DC is a tangent. ADC, this angle is 48. Work out the size of the reflex angle AOC. So it wants the size of this angle, but it's already marked there. I'll label it X. Right, looking at what circle theorems might apply, I've got a tangent and a radius, so I know that that's 90. And also at A here, I've got a tangent, AD, and a radius, so I know that that's 90. Now, have a look at this. This is a quadrilateral. And what do I know about the angles in a quadrilateral? I know they add up to 360. So I know that this angle here, which I'll call Y, must be 360 minus 90 minus 90 minus 48. 360 minus 90 minus 90 minus 48 means that Y is 132. So if this angle here is 132, I can work out X by doing 360 minus 132, which gives me 228. So the size of the reflex angle, AOC, is 228. Charlotte buys a painting for $680. The value of the painting increases by 4% each year. Work out the value of the painting at the end of 3 years. Give your answer correct to the nearest dollar. So we start with 680. It increases by 4%. So we're going to multiply by 1.04. And it increases by 4% for 3 years. So it's a compound interest. So I'm going to write 680 times 1.04 to the power of 3, which gives me an answer on my calculator of 764.907. Now that's in dollars, but it asks for the answer to the nearest dollar. So the answer I'm going to give is 765. Change the speed of 27 kilometers per hour to a speed in meters per second. Let's have a look. If it's 27 kilometers per hour, then it will be 27,000 meters per hour. So if I divide that by 60, that will tell me how many meters it is per minute. And if I divide by 60 again, that'll tell me, so I had that meters per minute divided by 60 again, and that will tell me how many meters it is per second. So I need to do 27,000 divided by 60 equals, divided by 60 equals. And I get the answer, 7.5 meters per second. After 11 rounds, Team A has a mean score of that. Well, I can instantly work out Team A's total after 11 rounds. That's going to be 11 times 17, which is 187. After 9 rounds, Team B has a mean score of 18. So Team B's total after 9 rounds is 9 times 18, 162. Both teams take part in the further round. After this round, both teams have a mean score per round of 18.5. In the further round, Team A scored more points than Team B. How many more? Right, so I'm going to need to work out how many points each team scored in the further round. So let's take Team A first. So Team A, this is going to be the 12th round. After 12 rounds, the mean's 18.5. So the total after 12 rounds must be that, which is 222. And so Team A's score in that round must be the difference between the total after 12 rounds and the total after 11 rounds. So that's going to be 222 minus 187. which is 35. So that's what Team A scored. Now, what about Team B? Let's have a look. Team B, they did a 10th round, and their total after the 10 rounds was 80. Their mean after the 10 rounds was 18.5, so their total was 185. So their score in that round would have been 85 minus 162, which is 23. So let's go back to the question. In the further round, Team A scored more points than Team B. Yes, they did. How many more? Well, 35 minus 23. Team A scored 12 more points than Team B. We've got a nonagon here, a 9-sided regular polygon, a regular nonagon. I'm going to start by drawing that line there. Now, the angle at the centre of a nonagon is 360 divided by 9, which is 40. So that angle is 40, and incidentally, so is that angle. Okay. If we have a look here, we've got a triangle FOK, and we're asked to find one of the angles in that triangle, this angle here, X. I've already got that top angle as 80. I wonder if I can work out this bottom angle here. Well, the answer is you can, because this is an isosceles triangle here. Top angle of 40, so bottom angles of 70. So that's 70 as well for the record, but we don't actually need that. So X is going to be the third angle in the triangle. I've got a top angle at O of 80 degrees, twice 40, and a bottom angle at F of 70, which means that X is 30 degrees. Question 12. A right angle triangle ABD. There it is. A couple of lengths are shown on the diagram and an angle shown on the diagram, and I'm asked to work out the angle, the length of CD, which is a small length here. Right. If only I knew an angle or a side in that triangle as well as the 8, then I could use trigonometry to get X. If, for instance, I knew this angle here, then I could use trigonometry to get X. I'd have to use tan, wouldn't I? Can I work out that angle there? Well, if you have a look at this large triangle, ABD, I've got 14 on the hypotenuse, and I've got an 8 on the adjacent, meaning that I can work out that whole angle alpha. So I'm going to work out the whole angle alpha and take away 38. All right, so how to work out the whole angle alpha? Well, I'm going to use cos alpha. Here's my cos. It's the adjacent 8 over the hypotenuse 14. So on my calculator, I'm going to go 8 divided by 14 equals and shift cos. Gives me an angle of 55.15 for alpha, 55.15, which means that this blue angle here is 55.15 minus 38. 17.15. So this angle here is 17.15. Okay. Get rid of that yellow triangle for a minute. Now we're going to look at this bottom triangle. I'll draw it here just to make it clear. That is there, that is CD there, and that's the hypotenuse. I've got a right angle here, got an angle of 17.15 there, I've got 8 here, and I'm asked to find X. Okay, well that's going to use tan. Okay, I've got an opposite here and an adjacent here. I'm trying to find the opposite. So the opposite X is going to be tan 17.15 times 8 times the adjacent. On my calculator, I'm going to put that in the other way around. I'm going to go 8 times tan 17.15, which gives me 2.4687, and I'm asked to give my answer correct of 3 significant figures, so my answer is going to be 2.47. There we go. That is number 12. Question 13. We've got 2 fair 6-sided dice. Dice A has 2 red and 4 yellow, and dice B has 1 red and 5 yellow. we're going to throw each dice once, complete the probability tree diagram, right? Well, dice A, the probability of getting a red is 2/6, and the probability of getting a yellow is 4/6. Dice B, the probability of getting a red is 1/6, and the probability of getting yellow is 5/6. Probability of getting a red is 1/6, probability of getting a yellow is 5/6. Okay, that's the probability tree diagram complete. Work out the probability that both dice land on yellow. So I'm being asked to work out the probability of ending up here, yellow, yellow. So I'm going to do those two probabilities multiplied together. 4/6 multiplied by 5/6. Obviously you can use a calculator. I'm going to go 2 into there, 2 into there. So I'm going to get 10/18, which I can simplify to 5/9. So the answer is 5/9. Question 14. I've got a circle, some points on the circumference of the circle, the centre of the circle at O. Okay, and I've got an angle. Find the size of angle. Let's find out what this one is. RQP. It's here, RQP. Now, that's a diameter. So this is the angle in a semicircle. So that's 90. So the answer is that RQP is 90. And the answer is that angle in a semicircle is 90. Okay. Find the size of angle PSQ. PSQ, that's this one. Okay. Well, here is a chord splitting the circle into 2 segments, and I see that there's 22, and the angle I want are in this angles in the same segment, aren't they? So they're equal. So the angle I'm after is 22. That is because angles in the same segment are equal. Right. Question 15. Right, we've got an expression here, which is to the power of 3/5. So to the power of a fifth, that's the 5th root. So I'm going to find the 5th root and then cube my result. So the 5th root of 32 is 2, and the 5th root of a to the 15 is a to the 15 divided by 5, a to the 3. And I'm going to cube that. 2 times 2 times 2 is 8. A cubed times a cubed times a cubed is a to the 9. Part B. Right, well, I've got something to the power of -3. So the first thing I'm going to do is find the reciprocal of that. And now it's to the power of 3. So this is just 10x to the power of 3. 10 times 10 times 10 is 1,000. And x times x times x is x cubed. Part C. I'm going to multiply the whole equation, everything in the equation, by something which 2, 5, and 3 all go into so that it cancels nicely. So I'm going to multiply everything by 30. Now, if I multiply something over 3 by 30, then I end up with 10 of the somethings. 4/5, if I multiply that by 30, well, I'm going to end up with 6 of the 4s, minus something over 2 multiplied by 30, I'll end up with 15 of whatever's on the top. And look out, I'm putting a bracket in there so I don't mess up my signs, because I've got a minus, a minus here. Okay, so multiply out that bracket. 10 minus 20y equals 24 minus 30y plus 15. So I've just got to solve this for y now. I'm going to add 30y to both sides, which gives me 10 plus 10y. And here I've got 24 plus 15, 39. Now I'm going to minus 10 from both sides, so 10y is 29, divide by 10, and y is 2.9. And that is the end of question 15. Question 16. Q is directly proportional to the square root of t. So that means that Q equals k times the square root of t. The graph shows the relationship between Q and t. Great. Find a formula for Q in terms of t. Well, let's find a point on the graph that'll help me. This point looks pretty useful. That point tells me that when t is 4, Q is 6. So I can substitute these values into this equation. So instead of writing Q equals k root t, I'm going to write 6 equals k root 4. Well, that means that 6 is 2k, which means that k is 3. So my formula for Q in terms of t is that Q equals 3 root t, because k is 3. So that's my answer for part A. Part B. Q is increased by 20%. Find the percentage increase in t. Well, perhaps the easiest thing to do here is to use the values of Q and t that I already know. I already know that when Q is 6, t is 4. And it asks me what happens to the value of t when I increase Q by 20%. Well, let's increase Q by 20%. So let's have Q being 1.2 times 6, Q being 7.2. Let's shove that in and see what happens to the value of t. Well, here's my formula connecting Q and t. And I'm going to put in Q as 7.2 and find the value of t. Divide both sides by 3. And then square both sides. So divide both sides by 3, tells me what root t is. Square both sides, and I work out that t is equal to 5.76. So when I've increased Q from 6 to 7.2, t has gone up from 4 to 5.76. I need to find the percentage increase in t. Well, the percentage increase then is 1.76 over 4, so that's the change over the original, multiplied by 100. And I discover there that t has increased by 44%. And so that is my answer to part B. And that is question 16 complete. Expand and simplify. So to start with, I multiply out these two brackets. So that's going to give me 3x squared. I'm going to get 18x from there, minus 2x from there, so plus 16x, minus 12. Now I have to multiply that by x plus 6. So I'm going to multiply each term by x, and then I'm going to multiply each term by 6. 6 16ths. Could have worked it out in my head by now. 6 16ths, 96. 6 12, 72. Okay, going to simplify this now. X squared, I've got 16 plus 18, so that's 34x squared. Plus, because minus 12 plus 96 is 84x minus 72 at the end. So that is part A done. Part B, make E the subject of this expression. Well, I'm going to start by squaring both sides. It's going to give me w squared equals E plus G over EF minus D. I'm going to multiply both sides by EF minus D. So now I've got rid of the square root and the fraction. Let's multiply out this bracket. W squared EF minus W squared D equals E plus G. Now I'm making E the subject. So I'm going to get everything with an E in it over on one side. So I'm going to minus E from both sides. It's going to give me W squared EF minus W squared D minus E equals G. And now I'm going to add W squared D to both sides, so that I've got only the expressions with E's on the left-hand side. So now I'm going to factorize and then divide. I'm going to fad it, factorize it, take out the E. And now I'm going to divide. E is G plus W squared D divided by W squared F minus 1. So now E is the subject of that expression. Question 18. Here are 6 graphs. Complete the table below with a letter of the graph that could represent each equation. Okay. Well, one of my equations is y equals sine x, and I know that sine 0 is 0, and I know what the sine curve looks like, so it's going to be graph C for my sine curve. Right, let's have a look next at this one here. Looking at that, I know that when x is 0, y is 0, and I know it's a cubic. Now, only one of my remaining graphs has the point 0, 0, and it's graph A, and that also looks like a cubic, so my answer is A there. Now, let's have a look at this one. Now, I know that y equals 1 over x looks like graph B. That looks to me like y equals 1 over x. And so y equals minus 1 over x. It's going to be that one reflected in the x-axis. So the answer is F for that one. So my answer is C, F, A for number 18. I've got to start with this expression, 3x squared minus 6x plus 5, and it has to end up looking like this. Well, I'm obviously completing the square here, but to start with, I'm taking out a factor A. So what I'm going to do is I'm going to take 3 out of there and leave my plus 5 there for a moment. Right. Now, can I complete the square here? Well, that's going to be 3 lots of. So completing the square here, I'm going to have x minus 1 all squared, which is going to add on another 1, so I'm going to have to take away the 1, plus 5. Okay, so I'm going to multiply out this bracket now. I get 3x minus 1 squared minus 3 plus 5. So that gives me 3 lots of x minus 1 squared plus 2. So now I believe I've written it in the form a x minus b squared plus c. So a is 3, b is 1, and c is 2. But it doesn't actually ask me for a, b, and c. It just asks me to write it in that. 12 counters in a bag, 3 red, 9 green. 3 people each take 1 counter from the bag. So now there are 3 counters out. The first one takes 1, second one takes 1, third one takes 1. Work out the probability that at least 1 red counter is still in the bag. Well, I'm going to work out the probability of the opposite of that not happening. I'm going to work out the probability of there being no red counters left, and then I'll take that away from 1. So i.e. the probability of the first person choosing a red, and then the second person choosing a red, and then the third person choosing a red. Probability of the first person choosing a red is 3 out of 12. Now, if that person chooses a red, then the probability of the second person choosing a red is 2 out of 11. And if those two both chose a red, the probability of the third person also choosing a red is 1 out of 10. So that's the probability of all the reds being taken. So let's just work out what that would be. It would be a quarter times 2 out of 11 times a tenth. Cancel there, cancel there. Of course, you'd probably use a calculator for this. But that is 1 over 20 times 11, 1 over 220. Okay, so that's the probability that all the red counters have gone. There are no red counters. So the probability that there is at least 1 red is 1 minus 1 over 220. So the answer is 219 220ths. The answer is it's pretty likely that at least one counter is left in the bag. Solve the simultaneous equations. Well, equation 2 gives me an expression for x. So I'm simply going to substitute that expression for x into equation 1. Here's equation 1. So instead of having 2x squared, I'm going to have 2 lots of 3y minus 1 squared. So now I'm simply going to simplify this. So I've got 2 lots of, I'm going to do it one step at a time so I don't mess it up. So I've got 2 lots of, right, I'll multiply up those 2 brackets, 9y squared minus 6y plus 1 plus 3y squared equals 11. Multiply out this bracket, 18y squared minus 12y plus 2 plus 3y squared equals 11. Let's tidy this up. 21y squareds minus 12y plus 2 equals 11. Let's minus 11 from both sides. 21y squared minus 12y minus 9 equals 0. So I've set it equals 0. Now I'm going to factorize. I'm going to take 3 out to start with. It gives me 3 lots of 7y squared minus 4y minus 3 equals 0. So now I'm left with trying to factorize this. Well, it's obviously going to have to be 7y and y, isn't it? I'm going to have 3 and 1. So I'm going to try 3 here and 1 here. And I'm going to do minus 1 plus 3, because that's going to give me minus 7y's plus 3y's. Okay, so my answers to the equation, but incidentally, you could have used the formula. You could have used the formula up here, couldn't you? But the answers are minus 3/7 or 1. So I need to find x for each of those possibilities. Now, x is simply 3y minus 1. So if y is 1, then x is 3 times 1 minus 1 is 2. And if y is minus 3/7, then x is 3 times minus 3/7 minus 1, which is minus 9/7 minus 1. Again, you'd probably do this on your calculator. That's minus 16/7, which is minus 2 and 2/7. But you'd have done that on your calculator perhaps. So my two solutions are that x equals 2 and y equals 1, or x equals minus 2 and 2/7 and y is minus 3/7. So there are my two solutions for question 21. Question 22. So in this question, I got a vertical flagpole, BF, and I've got these points, this triangle, which is on the horizontal ground. I've got some measurements shown, and it tells me here that D is the point on AC, so it's somewhere along AC, so that angle BDC is a right angle. So it's going to look something like this. Look. That BDC being a right angle. And I'm being asked to find the angle of elevation of the point F from the point D. So if you imagine F, the top of the flagpole, B, the bottom of the flagpole, go along the ground to D, you're being asked for this angle here, which I'll call alpha. Okay. Now, let's just start off with what we could find. The triangle on the ground, that 3 sides, the 9, 11, and 16 triangle, I'm going to start by finding the angle A here. And I'm going to use the cosine rule for that, because I know that cos A equals B squared plus C squared minus A squared all over 2BC. And in this case, I've got B equaling 9, C equaling 16, and A, the side opposite the angle, being 11. So if I substitute those in, I find that cos A will be 0.75, And so inverse cos that, and the angle A is 41.4. Okay, there it is, 41.4. Okay, now how's that going to help me? Well, the answer is that it's going to enable me to find the length of BD. And if I can find the length of BD, if you have a look at my triangle on the right here, FB is 10. If I only knew BD, then I could use tan to find that angle alpha. So now I'm going to be able to find the angle BD because I've got a right angled triangle here, and I can simply use Pythagoras, simply use trigonometry. So I've got A to D to B. I'm trying to find X, that's a right angle, that's 9, and this angle is 41.4. Right, so I'm going to use sine here. I'm trying to find the opposite. X will be the hypotenuse times sine the angle. And so that tells me, with a bit of calculator use, that X is 5.95. Right, back up here, that's 5.95. So now I can find the angle alpha, of course, because I know that tan alpha will be the opposite over the adjacent. Work that out on your calculator, inverse tan it, and you will find that alpha is 59.2 degrees to 1 decimal place. And that is question 22. Question 23. Right, I've got a cuboid, and its dimensions are x, x, and 2 root 5 minus 3, and its volume is as stated. So that means that x squared multiplied by 2 root 5 minus 3 equals 13 plus 6 root 5. And I'm asked to find the value of x. Right, I'm going to start by dividing both sides of this equation by 2 root 5 minus 3. It's going to give me 13 plus 6 root 5 over 2 root 5 minus 3. Right, I'm going to rationalise the denominator here, so I'm going to multiply top and bottom by 2 root 5 plus 3. Okay, all I've got to do now is to do that without messing it up. Right, on the top, I'm going to have 13 times 2 root 5, which is 26 root 5. I'm going to have 13 times 3, which is 39. 6 root 5 times 2 root 5, well, 6 2s are 12, and root 5 times root 5 is 5. And then I've got 6 root 5 times 3, which is going to be 18 root 5. Meanwhile, on the bottom, I've got 2 root 5 times 2 root 5, which is 4 times 5, 20. The middle terms disappear, minus 3 times 3 is 9. Okay, back to the top. Well, I've got 26 root 5 and 18 root 5, which makes it 44 root 5. And then I've got 39 plus 60, 99. And on the bottom, I've got 11. So x squared equals 4 root 5 plus 9. Now that gets you all the marks for this question except for one. And the last mark can be obtained by knowing that if x squared is 4 root 5 plus 9, we need to square root that. Now, simply writing the square root of 4 root 5 plus 9 is not enough. What you need to do is you need to work out what the square root of that is. So let's have a look. It's going to be something multiplied by itself, and it's got to equal 4 root 5 plus 9. Well, I know it's going to have some root 5s in it, so I'm going to start by putting my root 5s in. Now, those 2 root 5s will give me a contributory term towards the 9, won't they? Because root 5 times root 5 is 5. So I've already got 5 towards the 9, so I'm going to need another 4. So I'm going to try with 2 here. So if I have 2 plus root 5 and 2 plus root 5, I know I'm going to end up with the plus 9. And will I end up with 4 root 5s? Yes, I will. Therefore, x is the square root of 4 root 5 plus 9, which is 2 plus root 5. And that is question 23. Where's it gone? That is question 23 complete. Question 24. Now, beware, this question is a monster. Right, what I've done so far is I've plotted A and B and C, and I've joined them up in green there because that's the 3 vertices of my kite. Now, let's work out roughly where D will be. Now, the way I'm going to do that is to use the fact that the diagonals of a kite, so this line and this line, cross at right angles. That's going to be pivotal, knowing that. So I reckon that my point D is going to be here. And this is now my kite complete. Right. Okay. So what I'm going to do to solve this question is I'm going to work out the equations of the line AC. And I'm going to do that because I know a point on the line, A or C for that matter, and I can work out the gradient between A and C. And then later on, I'm going to work out the equation of the line BD. And I can do that because I'll know the gradient of BD because it's perpendicular to AC. And I know a point on the line, I know B. So I'm going to work out the equation of the line BD. Then I'm going to see where they cross. And that will enable me to work out the coordinates of that point there, which I'll call E. And then I'll have the coordinates of B, I'll have the coordinates of E, so I'll be able to work out the coordinates of D. Right, so that's the theory. So let's see how it works. First of all, AC. Well, A is the point minus 210, and C is the point 4 minus 5. So I can work out the gradient between those points, and so can you. And the gradient you should get as being minus 5 over 2. So that's the gradient. So now I'm going to work out an equation for the line AC. I'm going to use y equals mx plus c, and now I'm going to substitute in a point that I know, perhaps the point 4 minus 5. So that means that minus 5 is going to equal minus 5 over 2 times 4 plus c, and that will enable me to find c. If you do that correctly, you'll get that c is 5. And now we know that the equation of the line AC is y equals minus 5 over 2x plus 5. Okay, that's the equation of AC. Right, BD. Now we know the gradient of BD because it's going to be the negative reciprocal of the gradient of AC. So the gradient of BD is going to be 2/5. So I can start by writing y equals 2/5 of x plus c. And I know a point which lies on BD because I know the point B. So the point B is minus 27/5, comma 4. So that's going to give me 4 equals 2/5 multiplied by minus 27 over 5 plus c. And that's going to enable me to find c. And again, if you do that correctly, you will find that c is 154 over 25. So now I know the equation of the line BD. It's going to be y equals 2/5 of x plus 154 over 25. Right, so I know the equation of the lines, the equation of those two diagonals. I've got AC and I've got BD. So now to find the point where the two lines cross, I'm going to solve them simultaneously. So in order to find the point E, I'm going to solve the equations for AC and the equation for BD simultaneously to find the point that lies on both lines. Y equals this, y equals that. So this equals that. Now, if I solve that equation for x, and if you do that too, and we do it correctly, you'll get the answer x is minus 2/5. Now, how are you going to find y? Well, you can substitute that value of x into either one of your equations, and you'll find that y is 6. So E is the point minus 2/5, comma 6. Right, so E here is the point minus 2/5, comma 6. So I've got B is minus 27 over 5, comma 4. E is minus 2/5, comma 6. And I need to work out what D will be. Well, to go from B to E, I see the y coordinate has gone from 4 to 6. So presumably it's going to go to 8 when I get to D, because of course these two lines are equal. And what about the x coordinate? Well, it's gone from minus 27 over 5 to minus 2 over 5. So it's increased by 25 fifths. It's increased by 5, in fact, isn't it? By 25 fifths. So it was minus 2/5, so now it's going to be 23 fifths. And those are the coordinates of D. And that is the end of quite a complicated and drawn out question 24. Question 25. Right, I have a sphere which has a radius of 2.8 centimetres correct to 1 decimal place. So if it's 2.8 correct to 1 decimal place, then the upper bound of that will be 2.85 and the lower bound 2.75. Now the mass is m pi grams. So the mass is 260 pi grams. But the 260 is correct to two significant figures. So the upper bound will be 265 pi and the lower bound 255 pi. Now I'm asked to work out the upper bound for the density of the sphere. Now density is mass divided by volume. And I'm asked to find the upper bound of that. So if I want the highest possible density, I'm going to want the highest possible mass divided by the lowest possible volume in order to give me the highest possible density. Now, the highest possible mass, well, that's 265 pi. What about the lowest possible volume? Well, the volume of a sphere is 4/3 pi r cubed. And that, of course, is on the front of the paper for you. So my lowest possible volume will be 4/3 pi times the lowest possible radius cubed. So that is my lowest possible density. All you need to do really is to put that in your calculator without messing it up. You could, of course, divide top and bottom by pi to make it easier. So now you don't have to put pi in your calculator. But a bit of careful button pressing will give you the answer to 2 decimal places of 9.56. And that is question 5 done, and that is the paper complete. Mr. Wright here, and well done for making it through to the end of the paper. In a moment, I'll show you the grade boundaries, and I'll show you how to calculate what grade you would have got had you been sitting this paper or this set of papers. But first, if you found these video walkthroughs useful, please do hit like. It really helps the channel and it tells me that you have found the film useful, and it's good to have some positive feedback. Of course, if you want to see more of the same, do subscribe to the channel and then you'll get notifications every time I post something new. So, the grade boundaries. Well, here they are. And what you need to do is to add together your 2 marks on the 2 papers. Of course, both marks out of 100, so that gives you a total out of 200. And then you can use this table to read off what your grade would have been had you sat this set of papers. Leave me a comment, tell me how you've done,
and good luck with your exams.